Alright, so we have 5 more properties to go over, and I'm actually not going to do these in the same way. I'm just going to kind of state them and let you go from there. I will do some examples of equations where you do apply them in solving equations, but I won't use the scale in this one. So the first one is the distributive property. Now you have definitely heard of the distributive property and have done it before. And so just to kind of write out what it's saying here, so I'm actually, instead of writing these up here, I'm going to write them down here. So we're saying if A times B plus C, if that is true, then we can distribute the A and make that equal to AB plus AC. So you've done the distributive property before, and notice they write it in also the other order, but for our sakes, we'll usually have the constant on the left side. And so you've done this before. You know, if you're solving an equation, the first thing you would do in a problem like this is do the distributive property, which would then say, I'm going to take that 2. So I'm going to take this 2 and multiply it by everything on the inside. So that would give me 2x plus 2 equals 6. And then I would continue to solve it from there. But that would be applying the distributive property of equality. And so that's definitely something you need to keep in mind. Most people don't have an issue remembering that. The next property is the reflexive property. And I like to call this the duh property. And you'll see why in just a second. So the reflexive property says that for all values of A, so any real number A, that A equals A. Okay? Now, again, this is why I call it the duh property. Because it says A equals A. It's like saying 5 equals 5, or 2 equals 2, or -3 equals -3. Okay? When we say something equals itself, that is known as the reflexive property. And believe it or not, this will be one of the most used properties when we start doing proofs. And again, you won't understand that now, but you'll understand when we start doing proofs. So the reflexive property just says that everything is equal to itself, no matter what that something is. Okay. All right. Simple enough, right? Now the symmetric property is almost quite as obvious, but it says that if A equals B, then B equals A. Okay, so basically it doesn't matter what side of the equal sign it's on. And I could actually use the scale on this one if I wanted to. So if I came over here and I looked at the scale and I said, well, let's say we have some weight on here, we don't know what it is. And over here we have another something, and it's balanced. It doesn't matter if I switch those two. Okay, if I put the smiley face over here and the question mark over here, it doesn't matter what side of the weight is on, it's still going to be balanced, and that's all the symmetric property is telling me. All right, transitive property. This one's a little bit more in depth. The transitive property says if A equals B and B equals C, then A equals C. Now, this is also a property which will be used a lot when we start proving in geometry. So you want to make sure you kind of understand it. And so I want to kind of explain what this means. Notice, if I say A equals B and B equals C, well, if A equals B and B equals C, then obviously A and C also have to be equal. So to kind of explain this, again, using the scale, if I said smiley face weighs the same amount as check mark, so it doesn't matter, I'm just making things up. Okay, if I said those two are balanced, but then I said also that the check mark is also balanced with, let's say, the frowny face. Okay, I don't know. So if the check mark is balanced with the frowny face, and the check mark is also balanced with the smiley face, then obviously the smiley face would be balanced with the frowny face. And that's all the transitive property is saying. that if two things are equal to the same thing, then those things are also themselves equal. Okay, and I know that was kind of a full sentence there, but if two things are equal to the same thing, then those two things also must be equal. And that's the transitive property. Hopefully I didn't, maybe I'll explain that a little bit more in depth later. And then the substitution property I will save for another video.